Today we're going to continue with 7.2 and talk about story problems with the law of sines. In particular, we're going to be looking at two cases when you're using the law of sines. So we're going to have story problems with a mixture of remembering there can be two potential answers, and we got to consider those answers. First thing we have to do on story problems is make sure we draw them correctly. Let's take a look at this problem, and it says, number 24, a ship is headed due north at a constant of 16 miles per hour. That means we're going due north at 16 miles per hour. Because of the ocean current, the true course of the ship is north 15 degrees east. That's off the north direction, 15 degrees east is going to give you this. It's not like you can just draw the initial and then the impact and then the final. Now it's mixing it up. It's saying draw the initial and then the final and then connect them with the impact. So the connection is going to be the currents. The currents are going to connect the two at 14 miles per hour. The question is, in what direction are the currents running? In what direction are the currents running? So what that really means in terms of what we're trying to solve for is going to be focusing on this direction, but as a bearing. The bearing is either going to be off the south end or off the north end, depending upon what the angle is up here. All right. So at this point, what we're doing is we're looking to see what's given and what I can find. You're looking for the pairs, angles and opposite sides. 15 degrees goes with 14 miles per hour. 16 miles per hour goes with alpha. Eventually, I can get my theta. All right, so first I have to find my alpha, then I can get my theta. Sine alpha, I put my unknown first, over 16 equals the sine of 15 over 14. I've seen notation that's been a little bit sloppy here, so we want to be very careful with notation as we go through. This is now the sine inverse when you want to find the reference angle, and it's going to be the sine inverse of the whole thing. And that's going to give me my alpha, or not alpha, but my reference angle. And when I do that calculation, you get 17.21 degrees, thank you, which is going to be the reference angle. But I have to always remember that the sine is positive in both of those quadrants. So I have to do the supplemental angle of that, which is going to be 180 minus the 17.21, which is 162.79. And then you have to consider both of them. So when you consider both of them, you have to go back into the original and add the 15. 15 onto this gives you an angle that's less than 180, which means there's space. I have to deal with both of these angles. Now, this is my alpha. Now I'm going to subtract to find out what my theta is. Remember, to get your theta, it's going to be 180 minus 15 minus 17.21. And then you have to do the same thing for this angle. 180 minus 15 minus 162.79. And then you get 147.79 degrees and 2.21 degrees. That's my theta. That is not my answer. That is just my theta. So now I want to go ahead and write my answer. Well, if my theta is 2.2, that's the easy case because it's off the south end. So that answer is going to be south, 2.21 degrees east. But if it's obtuse, it's going to be coming all the way up here, which means now it's going to come off of the north end. And so I've got to subtract that number from 180. So it's 180 minus 147.79. And then you get 32.21. So that's going to be north 32.21 degrees east off the north end. All right, any questions on this one? So what do? We had to remember both cases. We ran both cases. Had to get my alpha, had to get my theta. Then I have to manipulate it just a little bit to get my bearing. Now, keep in mind the quiz on Monday is not going to be on these story problems. It's going to be up to these story problems. So it's going to be finding missing parts of triangles and considering two cases of triangles. Let's do one more problem because the homework is on story problems. And on this one, it's number 26 in the book. It says a boy is riding his motorcycle on a road that runs east-west. Now, one thing at a time when you're putting this together. A road that runs east-west tells you stop what you're doing, draw the east-west road. He leaves the road at some point at a service station and rides 5.25 miles in the direction of north, 15.5 degrees east. So I know it's going to be northeast, going this direction, and now I want to label. So 15.5 degrees, and this is going to be 5.25 miles. He turns right. That doesn't mean a right angle. He just turns right to get back to the road, and he drives 6.5 miles back this way. And the question is, and now his motorcycle breaks down. So the question is, how far back to the service station does he have to walk? Meaning, what is my X? Label what you're trying to find in the diagram so you can keep an eye on the target. So to find this, you're looking at this and you're going to see that this 15.5 is not helping you because it's not in the triangle. So the first thing I have to do is find the complement of 15.5, which is 74.5. Now that's inside the triangle. Now I can do some pairing. So I have an angle that pairs with 6.5. I also have a side here that's going to pair with this angle, but I don't know what that angle is. I can't immediately go after X because I have no idea what that top angle is. So I have to create a new angle, which is going to be this alpha. Once I get my alpha, I then can get my theta, which in turn I can get my X. In other words, I have to use law of sines twice here to get my answer. Let's go ahead and do this. So the first thing I want to do is find alpha. Sine alpha over 5.25 equals the sine of 74.5 over 6.5. And then you're going to get sine alpha and then you're going to do the inverse of this, which is going to equal your reference angle. And you should end up with the reference angle is equal to approximately 51.11. And I want to do the supplement of that because I have to consider both cases again on that angle. So I have to see that it's going to be 128.89 degrees. Now, when I consider both of those angles, then I have to go back in and check, does it make sense? The 51 and the 74.5 here would tell you that does make sense. There's room left for theta. But the other one, 128 and 74, does not make sense, which means I cross off that answer. I don't have to consider it anymore. Life is good because I don't have to deal with that second case. All right, but you always check, always check. So I'm running this case, and the next thing I need to do is that's my reference angle, but it's also my alpha in this case. All right. This was my possible alpha, but it didn't work. All right, so 51.11, I now go in and get my theta by subtracting the two other angles, and I get 54.39 degrees, which is my theta. And then at this point, remember, what I really want to do is solve for my x. I did all that work so I can actually use the law of sines again to get my x. Starting with your x over the sine of the angle you just found. And then you're going to say that it's equal to, now use the numbers that are given. Don't use the numbers that you found because you want to be as accurate as possible. 6.5 over the sine of 74.5. This one is more of a straightforward calculation of what your x is because you would just multiply both by this sine 54.39. And when you do that, you're going to see it's 5.48 miles, which in the story problem, it should make sense because you're looking at 5 miles, a little bit more in 6 miles, and coming back is probably a little bit more in 5 miles. It does make sense. So that's what we're talking about in that problem. Notice the difference in the problems. This first problem, what we did is I had to draw it accurately, I had to consider two answers, and then I had to run and get my other angle, and then I had to put in bearing form. And then I went back and I did the second problem, and when I'm looking at this problem, what I had to do is actually apply the law of sines twice, once to get an angle, and then the other one to get a side. So nothing is a certain way of doing these problems. You have to see how they're set up, and then possibly and possibly consider both cases if you have to run two cases. All right, the focus should be the setup. Double check the setup before you start solving them because you don't want to be going off of a wrong drawing.